All right, get ready to dive deep because today we're going behind the scenes of those incredible large language models, the LLMs you've been hearing so much about.
Yeah, they write like Shakespeare, code like prose, chat like your best friend, but there's a secret ingredient.
Spill it. What's the magic behind these AI marvels?
It's data. Mountains and mountains of data.
Data. Really, that's it.
Oh, it's not just data. We're talking billions, trillions of words fed into these systems. Imagine 1,000 libraries of Congress. That's the scale we're dealing with.
Whoa, okay, that's a lot of information. But why so much? It's not like they're memorizing the entire internet, are they?
No, no, it's not about memorizing. It's all about pattern recognition.
Patterns. How does that work?
Think about how you learn to speak. You are immersed in language, constantly hearing it in different situations.
Right, like from my parents, friends, TV shows, all that.
Exactly. Through sheer exposure, your brain picked up the patterns of grammar, vocabulary, even tone and humor.
So the more data an LLM gets, the better it understands and uses language, like a person who's actually fluent.
Precisely. One can string together sentences, the other, well, they can tell stories, write poetry, even crack a joke. It's about nuance.
That's fascinating. Okay, so where does all this data come from? What are we feeding these digital bookworms?
Well, the obvious one is the internet. Massive web crawling projects like Common Crawl gather billions of web pages and make them publicly available.
So it's like a snapshot of the whole internet.
Kind of, but raw web data is messy. Imagine a library after a hurricane. You've got duplicates, spam, gibberish, even personal info that needs to be removed for privacy.
So there's a whole cleanup operation involved.
It's a huge part of LLM development. Data cleaning filters out the junk, removes duplicates, ensures consistent language. It's like piecing together a coherent story from a jumbled mess.
I see. It's a lot more than just dumping the internet into an AI and hoping for the best.
Oh, absolutely. There's a real art to preparing this data. You can't just throw everything in and expect my masterpiece.
Makes sense. Okay, we've got this clean mountain of data, but how does an LLM actually read it?
Ah, that's where tokenization comes in. LLMs don't process language like we do. They break down words into smaller units called tokens, the building blocks of meaning.
Tokens. So like those you get at an arcade.
Sort of. Think of language as a deniant Lego set. Each word, or even part of a word, is a Lego brick, a token. They can be combined to build sentences, paragraphs, even entire stories.
So it's like a code for language.
Exactly. And there are different ways to create this code. Word-based tokenization is one, where each word is a separate token. It's simple, but struggles with rare words.
What about those made-up words LLMs come up with sometimes?
Right. Well, there's character-based. Each letter is a token. Good for rare words, but sentences get super long, like reading one letter at a time.
Ooh, that sounds tedious.
It is, which is why there's subword tokenization. Imagine Lego bricks representing chunks of words. These chunks can be combined to make any word, even new ones.
Interesting. So I like finding the most efficient Lego combinations.
Precisely. And we've got algorithms for that, like bright pair encoding or BPE. It finds the most frequent character pairs and merges them into single tokens.
So choosing the right tokenization strategy is important.
Absolutely. It's foundational. Like a house needs a good foundation, right? It influences everything from vocabulary size to how well the LLM handles those tricky rare words. It's crucial.
Okay, that demystifies tokenization a bit. But we've just scratched the surface of LLM data.
There's so much more to uncover.
And I'm ready to keep digging.
Let's do it. Welcome back to our deep dive into all this data powering these large language models.
Last time we talked about like the sheer volume of data these LLMs devour, right? And all those clever ways they break down language.
Yeah, into digestible chunks.
But now I'm kind of curious, like, how does an LLM actually learn? How does it go from a mountain of tokens to like this language whiz?
It's pretty fascinating. It all starts with this idea of self-supervised learning. So imagine giving the LLM a sentence, right? But you hide the last word and ask it to predict what comes next.
So it's like a giant game of fill in the blanks.
Exactly. And with each guess, it gets feedback. If it's right, great. If not, it adjusts itself to get it right next time. And it just keeps doing this over and over with tons of text.
So trial and error, but on a massive scale.
Yeah, supercharged trial and error, and there are ways to measure how well it's doing. We use this thing called a loss function to calculate the difference between its prediction and the actual word.
So like the smaller the difference, the better the model's doing.
Exactly. And to help it get closer, we use these optimization algorithms like AdamW. Think of it as a coach, guiding the LLM's training.
It's like a personal trainer for AI.
Yeah, that's a good way to put it. And just like with a personal trainer, there's an art to finding the right balance, right? Adjust too quickly, it could overshoot and get worse. Too slowly, and it takes forever.
So you're actively monitoring and adjusting.
All the time. Now, there's another challenge you got to think about. It's called overfitting.
Overfitting? What's that?
So imagine a student who memorizes all the answers to a test without actually understanding the material, right? They might ace the test, but they don't really know the subject.
So they can't improvise or apply that knowledge in different situations.
Right. Same thing can happen with LLMs. If they get too focused on the specific examples, they might struggle with new, unseen text. So to prevent that, we use techniques like dropout. It randomly silences parts of the model during training.
So it's like forcing it to think on its feet to be more flexible.
Exactly. It's like a jazz musician, right? They got to be able to improvise. Now, all this we've talked about, this is pre-training, like giving it a general education in language, but to get it to really shine at specific tasks, like writing different types of content or translating languages, we need fine-tuning.
So pre-training is like the foundation, and fine-tuning is where you specialize.
Exactly. It's like grad school. We train the model on a smaller, more focused data set, relevant to the task.
And there are different approaches to this, I'm guessing.
There are. One is supervised fine-tuning, where we give it clear examples of inputs and outputs, like showing a chef a recipe, right?
Learn by example.
Yeah. And then there's instruction tuning. It's like giving the LLM a set of instructions to follow, makes it more versatile.
Like training it to be your personal assistant.
Right. Then we've got preference fine-tuning. This is where it gets interesting. We're talking subjective judgment here.
Subjective. So like style, taste, even humor.
Exactly. Those things that are hard to define but easy to recognize, like is a joke funny? Is a piece of writing engaging? That's where preference fine-tuning comes in. We can use things like reinforcement learning from human feedback to train the model.
So teaching it to have good taste.
That's one way to put it. And the crazy thing is, we can use other LLMs to help with this.
Whoa, AI training AI. That's mind-blowing.
It is, but it also raises questions, about control and oversight. Making sure these systems stay aligned with our values, that's a big one.
Definitely seems like the more powerful they get, the more crucial these conversations become.
Absolutely. And it's not just about ethics. There's the environmental impact, too. Training LLMs takes a lot of energy. So there's research into making it more efficient using techniques like model parallelism and quantization.
So like making it less resource intensive.
Exactly. And it's all because the potential is just so huge. They're already changing things like natural language processing, and their applications are just getting started. As these models become easier to train, we'll see them everywhere, from writing and translation to like customer service and even creative stuff like music and art generation.
It's mind-boggling to think about.
It is. But let's bring it back down to earth for a second. We've talked about this training process, but can you give me some real-world examples? What can they actually do?
Yeah, let's get concrete.
Okay, so one big one is text generation. They can write stories, poems, articles, even code, and it often sounds just like a human wrote it.
So could an AI write the next bestseller?
It's possible. There's already AI-generated art and literature out there, and it's not just creative writing. They're being used for news reports, ad copy, even personalized learning materials. They're becoming super versatile.
Like a Swiss Army knife for language.
Exactly, but it goes beyond that. They're also amazing at translation, powering chatbots, and even helping with scientific research.
Wow, they really are breaking down those barriers between us and machines.
That's the goal, making it more natural and intuitive to interact with technology. That's what makes this so exciting, this paradigm shift in how we deal with information and technology.
Huge potential there. Okay, but where do we go from here? What's next for LLMs? Have we reached the peak, or is this just the beginning?
That's a good question. We've made incredible progress, going from basic models to these complex LLMs doing things we never thought possible.
We've come a long way fast.
For sure. But remember, we're still in the early stages. There's so much work left to do, from efficiency and scaling to accuracy and reliability.
We've climbed one mountain, but there's a whole range ahead.
That's a great way to put it, but that's also what makes it so exciting. There's so much more to explore, so much potential to unlock. And the more we understand, the better we'll be able to handle the challenges and use this power for good.
Cautious optimism.
Yeah, that's the spirit. So that wraps up part 2 of our LLM deep dive. We've gone through the whole training process, from self-supervised learning to fine-tuning. It's amazing what these models can do.
And we're back for the final part of our LLM deep dive, where we've been exploring this incredible world of data behind those large language models.
We've covered a lot, from the sheer volume of data to the training process to what these AI systems can actually do.
Yeah, it's been mind-blowing. But I think what sticks with me is like LLMs are ultimately tools, right?
You got it. Powerful tools. But their impact, good or bad, depends entirely on us, on how we choose to use them.
So it's like giving someone a super powerful telescope. They could explore the universe, or they could, I don't know, spy on their neighbors. It's all about intention.
Exactly. So the question is, how do we ensure these LLMs are used responsibly and ethically? What's being done?
Yeah, what safeguards are in place?
Well, transparency is a big one. We're making these models more understandable so we can see how they make decisions, identify any bias, stuff like that.
So, like lifting the hood and making sure everything's running smoothly.
That's the idea. We're also working on methods to align these models with human values, making sure they prioritize fairness, accuracy, and safety, building in a sort of moral compass.
That makes sense. But this isn't just a job for the tech folks, is it?
Not at all. We need everyone at the table: ethicists, social scientists, policymakers, even the public. The future of LLMs is too important to leave to just one group.
A collective effort, I like it. That's reassuring.
And it's ongoing. The LI world changes so fast, we have to be adaptable, always learning and adjusting as the tech develops.
It's a journey, not a destination, right?
Couldn't have said it better myself. And this journey could reshape the world. LLMs are already changing communication, learning, creativity, even how we think.
It's incredible to witness, honestly.
It is, but we have to remember it's still early days. There's so much potential to unlock. And the more we understand, the better we can navigate the challenges and use this power for good.
I like that, using this power for good. Okay, before we wrap up, one last question, a little personal one. You've shared so much about how these LMs work, but what awe inspires you? What gets you excited about this work?
That's a good question. I think it's the potential to actually augment human intelligence. They're not here to replace us, but to enhance us, help us think differently, explore new knowledge, new ways of expressing ourselves.
A powerful tool for the mind, right?
Precisely. And I'm also excited about the real-world impact it's already having, helping people with disabilities communicate, breaking down language barriers between cultures. It's pretty amazing to see.
Yeah, it's like we're weaving a more interconnected world, thread by thread, through language.
I love that. That's what makes this field so compelling. It blends technology with human values, and it holds this promise of a brighter, more connected future. It's inspiring stuff.
It really is. Well, on that inspiring note, we'll wrap up our LLM deep dive. We've explored these massive data sets, the training process, and the incredible potential of these language models. Hopefully, you've gotten a better sense of how complex it all is, but also the power and responsibility that come with shaping this future.
It's been a pleasure sharing this journey with you all.
And thank you for joining us. Until next time, keep exploring, keep questioning, keep learning. The world of LLMs is huge, and it's always changing. There's always something new to discover.